Every time you learn a new tool or concept in a programming class, it's really useful to go backward and connect it to everything that you've learned so far in that programming language. So in our case, we are learning about arrays. We are going to try to mix arrays and function and see how they work together. So let's take a look at some code. Let's jump right in. So the first thing that we can do with an array, so let's say that I have an array of data I'm going to initialize like so. So let's go for the series of powers of 2, 2, there we go. So I have an array with some data, and I'm going to have a function here, void display data. It's not going to display the whole array as you're going to see, not at first at least, but it's going to display some information. So maybe I should just call it display. There we go. The first thing I can do is call that display function and give to it one of my elements in the array. So I select it using the index notation. Okay, so this is element index 0, element index 1, element index 2, element index 3. So this here is an argument. I remember an argument is an expression that's going to be evaluated into a value, and that value is what is passed to the function you're calling. So in this case, the expression is data index 3, so that's going to evaluate into the value 32, and 32 is the value that I'm passing to my function. So do I need to have any special notation here when I declare the parameter? No, it's an int. Okay, each element of the array is an int in this example. That would work with double, float, etc., long. So you can extrapolate that to all the data types that we covered so far, right? But in this case, I'm passing a value that is an int. So I'm going to declare my parameter as an int. Whether that int comes from a variable, like int x equal 42, okay? Whether the int comes from a variable, comes from one element of an array, comes from a complex expression, etc. That doesn't matter, okay? For the function, it doesn't matter. As long as you give me something and I receive an int at the end, I'm going to be just happy with that declaration. So for example, here, 3 different examples. One where I pass the content of the variable x, then I do something with the variable x, so I have a full expression. Then I have here the content of element index 3 of the array data, or I could have a more complex expression here that says I'm going to take this and multiply it by 2. Okay? In all of those cases, I'm going to receive at the end a value, and I can say printf %d. So I'm going to prefix it with something so that we know where it's coming from in the display. And I'm going to display just the value that you passed to me. And we should see different values being passed here to the same function. Let's compile first, get rid of compilation error. There we go, implicit declaration. So we need a prototype up here, void display text an int. Okay, and we're going to recompile. This time it compiles without problem, run it. So the first time on line 11, I call display with x, so x is equal to 42. So if I pass the value 42, which end up assigned to the parameter named value and displayed here. The second time I do x plus 23, so 42 plus 23 equals 65. That value 65 is what is passed to my function. So that's what's assigned to the parameter named value, which is then displayed here. When I call with data index 3, it's just another expression. That expression finds an element inside an array at index 3. So this is element index 0, 1, 2, and 3. And this is 32, so I'm displaying 32. And here I take that same element, multiply it by 2. So I get 64 as a result of this expression here. And 64 is passed to display, and here we are. Okay, I display the value 64. Okay, so that's the first thing we can do with an array and a function is we can say, I'm going to pass one element of the array as an argument to my function, which is going to receive it inside a parameter and do something with it. Okay, But that's not really the most interesting part. Okay, the most interesting part is when we start passing an entire array to a function. For example, here we would do something such as display, and I want to display everything inside data. So I don't pass data index something, right? A specific index element. I pass the whole thing, the whole array that I referred to by its name. How do I declare this on the receiving end? Well, the same way that I declare arrays. I can say square bracket here, and that makes value actually, which I should put as plural now. Values is an array of int element. And you will notice that I don't even have to specify the size. Okay, this is between the square bracket. This is going to work with any array of any size. And we'll see more about that and why it is so when we discuss pointers, okay? But for now, I can declare it like this, okay? And it would be actually compiling, and I need to update the prototype to say that this is an int square bracket, so an array of int. It would be compiling, but what am I going to do here? Well, for example, I could decide that I'm going to display one of the elements, like the first element. There we go. Every time you pass to me an entire array, no matter how big it is, I'm going to display the first element. So GCC, value undeclared, yes, now I called it values. So here we are. GCC again, a.out, and it displays 4. Okay, but what if I want to display all the elements of the array? Well, we're going to need a loop, right? We're going to need something like for size t I equals 0, I lesser than whatever the size of the array is, I plus plus, and then I want to display on the screen. There we go. I want to display something such as element %d is %d, and I'm going to display I followed by values of I. Okay, so I'm just using what I learned to do already before. Okay, nothing really tremendously difficult or new yet. But here's the thing: where do I get the size from? So in other programming language, you generally do something like values.size, or maybe value.size with parentheses, or maybe value.length with or without parentheses. I mean, every language has its way to extract the size of an array from the array itself. Well, not in C. We have a way that we could use, but it involves, the size of operator. I'm going to leave that for a little later when we discuss again about pointers. The discussion about pointer is going to recast a new light on everything that we have seen so far, like strings, arrays, etc. So be prepared for it. But here, without resorting to pointer-related tricks or things like that, size of operator, I don't have an easy way to get the size of this array. So the convention is we can do different things. Okay, one thing we can do is we can say, for example, I'm going to have a symbolic constant, define size, and I'm going to say my size is 4. And when I use size here, it's a little bit dirty, right? Because size is kind of like a global constant to all my file. I could use it here to specify the size during the definition, okay? I could use it here to specify the size during the declaration, and I could use it here to specify the size while I iterate. So I could use that constant size everywhere. And that's one of the possible solutions, okay? That's been used in the past, no problem. You have a symbolic constant that represents the size of a specific array or family of array you're going to use in your code, and every time you define them, declare them as parameter, or iterate over them, you refer to this. Let's see if this works. There's this. GCC main. Wanting %d expect argument of type int. Yes, I'm displaying here I as a %d, but it should be ZU because I'm using the data type size t. So let's fix that. There we go. A.out. So 4, 8, 16, 32. It's working, no problem. But several things. First, because I use a symbolic constant, size is known at runtime. Sorry, it's known at compilation time. Okay, so that means that it's actually known even before compilation by the precompiler, which replaces every occurrence of the word size, all uppercase, by the value 4. That's what the pound define precompiler statement does. Okay, for us. So what if I had a size that's going to be only known at runtime? Well, I cannot use that trick. So how would I go about making things a little bit more flexible? Well, let's remove this first, okay? So I know I don't need to specify the size here if I specify list initializer like this, okay? I know I don't have to specify the size here either if I don't want to, but then how do I get the size here? Well, the first obvious way of doing this is to add a parameter, okay? And I should say this is a second obvious way of doing this, okay? We add a parameter here and we say I'm going to be given the size of my array as an additional parameter. So every time you pass an array that is going to have different size as an argument, you have to specify its size when you call the function and use that parameter size here to iterate over the array. So when I call display with data here, I specify the value 4. And that allows me to make things very flexible, okay? So now I could even imagine a situation where I know only the name, I know only the size of my array during runtime. And here I had a small error here where I forgot to update once again my prototype. So let's fix that. And this is the next version of the code we are going to do. We're going to do a version of the code where we're going to ask the user, how big of an array do you want? And then we're going to use that in the code. So let's go ahead and do this to show that this version is a lot more flexible. Printf, how big of an array? And I'm going to say I have int size here, and I do a scanf %d of and %size. Okay. And then I'm going to declare int data index size. And because the size is variable, I cannot initialize it with a number of elements that I know already at the compilation time. But what I can do is I can do a for loop size t I equals 0, I lesser than size, I plus plus. And inside the for loop, I'm going to do scanf %d, and I'm going to read some data inside data index I. And yes, I should put a little prompt here to make things a little nicer. So printf, and I'm going to say inside the printf, I want to display data index %zu equal, or an arrow, like give me the value, and then I'm going to let the user enter that value, sorry. And when I call here the function, I'm going to pass the array data, but since it has been sized based on what the user typed, okay, I'm going to pass that value as well, and it doesn't change anything for my function. My function still says you're going to give me an array. I don't know how many elements, but you're going to give me an array of int. And then you're going to give me a second parameter that tells me how many elements are in the array. And I'm going to use both to do a for loop, line 25, 26, 27, to iterate over every element of the array and display them. But of course, that means that you don't mess up. Okay, if you give me here, instead of size 23, then your program is going to probably crash. Okay, depending on how big the array is, how big the number that you give here is, you may cause actually this poor little function to try to go way past the end of the array. Okay, so you have to be careful about that. You have to manage yourself passing both the array and its size without mistake, without errors, to the function so that it may work on the array. Let's compile this, get rid of the compilation errors real quick. From a ZU, expect a matching size C argument. Yes, I thought this is what I had. Well, no, I forgot to specify here that I wanted to display I. So there we go. It should work out better now. And then A.out. How big of an array? I don't know. 8 elements that are index 0. 1, 2, 3, 4, 5, 6, 7, 8. And then element 0 is 1, 2, 3, 4, 5, 6, 7, 8 for element 7. There we go. We are done. Okay. So we have covered how to pass one element of an array to a function, which is very basic. Okay. We have covered how to pass an entire array to the function. Well, now let's talk about what the function can do with this array, because this function here, display, doesn't attempt to modify the array. But let's say that I have another function, which I'm going to quite appropriately call modify, and that function is going to also operate on an array, okay, as parameter. But what it's going to do, it's going to say, okay, you give me an array of size, that's the name of my parameter, so I'm going to go to the last element of that array, and I'm going to say the last element of that array, which is at index size -1, always, no matter what size is going to be set to a special value, let's say 42. Okay, that's it. All right, so this is doing something that we have not been able to do until now. Until now, when you pass an argument to a function, you evaluate that argument into a value, you pass the value to the function receives the value in a parameter, and if it decides to change a parameter, well, that doesn't affect at all, any of the variable in the main. Every function has its own variable. When you pass an array actually to a function, an entire array to a function, you pass actually the address of the first element of that array, the memory address of the first element of that array. And this is what we are going to explore much deeper when we cover pointers, okay? But for now, the recipe that I want you to learn and to memorize is when you pass an entire array to a function, you give pretty much the keys to the car to that function. You give it the right to access the inside of your array. It has the keys to the kingdom. It can go inside the array and read the element and display them like we did here, but it can also go inside that array and modify the value therein. Okay? So it's different. It's different than when you pass an int, when you pass a double, when you pass a float, when you pass a char. I mean, all of those situations we have encountered before, okay? And we know how they work. But now what we are saying is that if you pass an array of int, an array of float, an array of double, an array of char, an array of long, if you pass an array of anything to a function, the elements of that array are not quote-unquote safe. Okay, they can be modified by the function, and that's going to impact what happens in the array as seen by the main. Let's make a proof of concept code here. I'm going to display the content of the array data. Then I'm going to call modify, okay, and I'm going to modify the last element of the array data, and then I'm going to once again display the whole array so that we see the difference. We see that the last element has been modified. Okay, let's go back here, compile. Implicit declaration of function modify, yes, I need also here, there we go. I need a prototype, modify, there we go. And I'm going to compile again. This time it's working, a.out. So how big of an array? We're going to make it a little smaller so that we don't have like a ton of stuff on the screen. So 3 elements, 1, 2, 3. So element 0 is 1, element 1 is 2, element 2 is 3. Okay, so this part is displaying the array, and this is what we did here with this call on line 18, sorry. Then line 19 calls the modify function, which is going to modify the last element of the array, and I display again the entire array here on line 20. And when I do so, then I get element at index 0 is 1, element at index 1 is 2, element at index 2 is 42. So this has been modified. The element at index 2 was 3, now it's 42. That's exactly what we do in our little function here. Okay, so we saw that when we pass an entire array to a function, it is possibly modified by the code of that function. And when we return from the function and we look again inside the array that we passed, we are going to see those modifications. So this is, in a way, this is neat, because that means that there is a way to easily have function able to operate on array, doing something that is related to what people call passing the data by reference. Okay, I'm passing my array, my entire array by reference, so that it's not just passed by value. I don't just make a copy of the value. I allow the function to modify the content of my array. But what if I don't want this to happen? Okay, if I don't want this to happen, I need a mechanism that allows me to say, you know what, this array here, I want you to treat it as an array of int data type elements, but those elements, they have to be untouchable. Well, the untouchable keyword in C is const, which I misspelled. Const for constants, okay? Constant, sorry, not constants. It's a nice name, but has nothing to do with what we're talking about here. So const for constant is actually a keyword that's going to allow me to say values is a parameter, which is an array of constant int element. And so that's going to prevent modification of those elements. So it's a way to declare your function so that you are not going mistakenly by error, you are not going to modify the content of an array that was given to you as parameter. Even though they give you an array, they should expect that you can modify it, but what if you don't want to? Then you have to change here the definition. So I can update I should update definitely my declaration here, my prototype. Then I'm going to compile again, but it's still telling me, and this is a good error, this is the one that's interesting actually, error assignment of read-only location. So when I try to do this on line 34, when I come here, you see that the hat symbol, the caret, indicates that the compiler had a problem when it encountered the equal sign, the assignment operator. When I try to assign 42 to this element inside the array, the compiler realized that I declared it that my parameter was going to be a constant int array, an array of constant int values, and therefore I cannot modify those values. So we have a way by default to allow the content of arrays to be modified by function, and when we want to avoid, mistakenly doing so, we have a keyword const that allows us to turn off that feature temporarily, okay, just for that parameter. Okay. Last thing we are going to discuss, it's related to variable length arrays. So again, you're going to find out more about variable length arrays in the reading assignment. But for now, you see the way that we have omitted here the size because we're declaring it as a variable. Well, you can, since, and again, I'm going to use my memory here. I should really not rely on it, but since I'm going to say C99 with the introduction of variable length array, you can now actually specify between the square bracket here something that is not just an expression or like a symbolic constant that is known only at computation time, but something that is a variable, like a parameter that is going to be known at runtime. So only when I call this function, I know exactly what I'm calling the function with, right? The value of the parameter size. Well, I can use that value to let the compiler know that the size of this array is actually the size that is specified here, okay? In practice, the compiler doesn't do much checking. It's going to make sure that this is not a negative value, okay? So if you were writing a constant here like -1, it would catch that at compilation time. At runtime, it's going to be able to do a little bit more, okay? But it's not the compiler anymore. I should change the subject of my sentence, okay? The runtime is going to be able to check a little bit more here that things are indeed what they claim to be. But that's about it, okay? Very simple syntax. Those of you who are coming from, I was going to say those of you who are coming from a language like Java, that should sound familiar, but it's not entirely true because in Java things are a little bit simpler. So far, the experience that you should be getting out of manipulating arrays in C is that it's a lot more primitive than what you have been used to in other programming languages that are more modern, like Java, Python, etc., even C++, does things a little bit differently. So you're going to go back like a level of abstraction down here and really learn how to manipulate those arrays at a very, very basic level. Okay, so that's it for arrays and functions. As usual, thank you for your attention, and don't hesitate to ask questions for on Piazza, depending on what we're using this semester, but also office hours. All right, see you in the next video.